What's up guys, welcome back to Ubad's lab, and today we're going to be extracting bismuth from Pepto-Bismol. Bismuth in its metallic form is very brittle, and it forms the very unique crystal structures that look like a staircase. The crystals that are formed are very colorful, and these colors are due to the differing variations in the oxide layers on the crystal. Bismuth is used in different industries such as pigments, cosmetics, and in pharmaceuticals. An example of its uses in the pharmaceutical industry is the use of bismuth subsalicylate in Pepto-Bismol in order to treat upset stomachs. In 2003, it was discovered that bismuth is actually very slightly radioactive. So this is the reaction that we're going to be using in order to extract the bismuth from the bismuth subsalicylate, which is inside of the Pepto-Bismol. So bismuth subsalicylate reacts with hydrochloric acid, and that forms salicylic acid, bismuth chloride, and water. And then we're going to be isolating the bismuth from the bismuth chloride later on. Gloves and protective eyewear should be worn at all times since we're going to be handling hydrochloric acid, which is a strong acid. Also, this experiment should be done in a well-ventilated area since toxic vapors can be released. The equipment includes Pepto-Bismol. This can either be in the tablet form or in the liquid syrup form. We're going to be using the liquid syrup form. Hydrochloric acid, which will be reacting with the Pepto-Bismol in order to extract bismuth chloride. Aluminum foil, which will be reacting with the bismuth chloride that was produced in the previous reaction in order to extract bismuth. And then distilled water. Okay, so I have all my reactants over here. So I have the hydrochloric acid, the Pepto-Bismol, and some distilled water. So first, I'm going to start off by pouring some distilled water into the erlenmeyer flask. And it's only going to be just a little bit, just 25 milliliters about. Okay. Okay, and now that the distilled water's in, we're going to be slowly adding some hydrochloric acid to the mixture now. And this is going to be around 100 milliliters of hydrochloric acid. And I'm just going to mix it a little while adding. Okay. Now that the hydrochloric acid has been added, I'm going to add the Pepto-Bismol. And this is just going to be around 50 milliliters of Pepto-Bismol since we need an excess of hydrochloric acid for this reaction to take place. So just around 50 milliliters. Okay, let me close that up. Okay, and for this reaction to take place, I'm going to start mixing this a little bit. So the reaction is starting to bubble up and become a little bit of a cloudy color now. Hopefully some bismuth chloride is beginning to form. I'm just going to let this sit for a little bit and keep on mixing it to let the reaction go to completion. So I've let this reaction sit for around 30 minutes now while regularly mixing it. So we should have some bismuth chloride and some salicylic acid in this as well. And now we can move on to our next step of separating the bismuth from the bismuth chloride. So now we're going to be preparing some aluminum to add to the solution, and the aluminum and the bismuth chloride will react to form bismuth, and this will be our final way of extracting the bismuth. So first, I'm going to start off by cutting this aluminum foil into tiny bits to increase the surface area and make the reaction go faster. Okay, and now I'm going to transfer all this aluminum foil into a mortar and pestle to help it get grinded up even further. So I grinded up the aluminum foil pretty well now, and I'm just going to add this to the beaker now, just to show you guys what it looks like. So this is what I got, and this will just help the reaction take place way faster. And I'm going to add this aluminum foil to the flask now. Okay, and now that's been added, I'm gonna mix this a little bit. And this reaction should produce some bubbling, some hydrogen gas should be released, and then the bismuth will also be separated from the bismuth chloride during this reaction. And to help this reaction take place, I'm gonna heat it up a little bit on a hot plate. So I let the reaction sit on a hot plate for a little bit, and out of nowhere it started producing this cotton candy pink looking solid, and I believe this is the bismuth that has finally separated out. So now I'm going to be filtering this out to separate out the bismuth that has now formed. And I'm going to be running it through some filter paper now. It's filtering through quite fast, but the only problem is that the aluminum foil is also going to be at the top on the filter paper, so we might have to figure out a way to get rid of the aluminum foil as well. Once this is done filtering out, we should have just left on the filter paper some aluminum foil and some bismuth, and we should be able to just pick out the pieces of aluminum foil since they are kind of big clumps, and then we'll have a final product of just bismuth. So while this is filtering out, I've just been picking out some of the aluminum foil bits and putting it over here to make sure this is just pure bismuth. And this is going to take a while, and most likely I'm not going to be able to get all the aluminum, but in the end it should be mostly bismuth. So now that's finally done filtering out, and I've picked out most of the aluminum foil. I'm going to transfer it to an erlenmeyer flask, heat it up a little bit on a hot plate, and then put it into a cold bath, and that should hopefully recrystallize and make it much more pure than it is now. So I'm going to get it into this erlenmeyer flask. Okay, and as you can see, it's this pinkish goop, and there are some aluminum foil bits in it. And I'm just gonna go heat this up now. So I heated up the bismuth for a little bit, and now it's back to a thick liquid form, and I'm gonna put it into the cold bath, and it should go back to its solid form. And I'm just going to leave it in there for a little bit. So it actually didn't go back to its solid form, but I put it into a test tube anyway, and this is our final solution of some bismuth and aluminum. Thanks for watching, guys. Don't forget to like, subscribe, and hit the notification bell if you enjoyed the video. Also, feel free to ask any questions in the comment section. Stay tuned for my next video where I work through another general chemistry problem. Alright, I'll see you guys next time.